Hi, Bikdip. I know you don't care, but I was watching Big Mac by Gillette recently, and he always posts these awesome math videos, and I want to be super awesome cool like the Big Mac, and so I'm going to do the math video too. This is the triangle puzzle from your video, Mystery of Time and Space, Part 1 of 3. I'm just started Part 2 here watching it, but I managed to find the puzzle here. It's called Simeon's Triangle Puzzle. At least the version I found was called that. And that's Simeon as in the old time Simon, not as in monkeys and apes. Simeon. You have these two supposed right triangles here, and then apparently if you rearrange the pieces around, you get this empty space. How can that be? How is that possible? And if you can confirm real quick that all these pieces are the same size. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 2 by 5, 2 by 5. This one is 5 and 2, and this one is 3 and 5. So there you are. There's two ways to show this. The easiest way, and easiest just by thought process way, area. This whole triangle is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And obviously the line here matches up down, and this one is 1, 2, 3, 4, 5 tall. So they both have an area of 5 by 13, but they're triangles, so you have to have it. And 5 by 13 divided by 2 is 32.5. All right, so they should both have an area of 32.5 units. This one, and just adding up the pieces here, all right, the dark green piece is a 2 by 5, and it's a triangle. So 2 times 5 is 10, divided by 2 is 5. The orange piece has an area of 7. That's just simple adding. The light green piece has an area of 8, and the red piece has an area of 3 by 8, which is 21 divided by 2 is 10.5. 5 plus 7 plus 8 plus 10.5 equals, oh my gosh, it's 30 and a half. That's not 32.5. There's a problem here. Already, we have an area that is too small. And even at the bottom piece, since all the pieces are the exact same size, you have 30.5 as an area plus that one empty space is 31.5, which is still not enough area for that triangle. What could be the problem here? Well, the way you confirm it is with slopes. This is 5 by 13, so this triangle should have a 5 by 13 slope, and this triangle should have a 5 by 13 slope. The rule of similar triangles says that if this has a 5 by 13 slope, then this green triangle has to have a 5 by 13 slope, and this red triangle has to have a 5 by 13 slope. Well, this green triangle has a 2/5 slope, and the red triangle has a 3/8 slope, which, funny enough, neither of those is 5/13. And 5/13 is two prime numbers, so it doesn't reduce down at all. Since they don't have the same slopes, that means that these two triangles are not similar, therefore they do not share one straight line slope. If I went ahead and exaggerated this a little bit, what's actually showing up here is that you have the base, which is flat and straight. We agree on that. You have the height, come here, which is flat and straight, and we can agree on that. But it's not doing one straight line hypotenuse like that, which we would expect. It's actually doing this. This is a bit exaggerated, but that is exactly what one of them is doing. And the other one is actually doing this. And that is why you end up with the wrong area. It's because these are not similar triangles creating one hypotenuse. They are this entire figure is a quadrilateral. It's four-sided. It's just that these two are close to being one big straight line, and when you use a thick line like this, it looks like one big straight line. So you lose that little bit of area there, but it gives you the appearance of a single straight triangle hypotenuse. That is why you can end up with this extra space in here, because this one, by maneuvering it around, you actually end up with a little bit more along the edge here. These are not similar triangles. They don't share the correct slope for the line, and hence you get this little bit of extra space. All right, that is exactly how this problem works and why it is an optical illusion, because you're technically kind of cheating here to make it look like one straight line, and why it's a trick, because you're presenting this as being a triangle when it's not really a triangle. It's a quadrilateral with four sides. This right here is an angle, like I showed in the paint. So there you go. I now have an awesome, cool, super duper math video on my channel. And there was another super duper math video that I wanted to do, but I haven't done it yet. And that's on calculating square roots by hand. But that's going to be kind of boring, and I have to sit down and do it, which I haven't. So there you go. And I know Bikdip probably hasn't watched this video past the introduction, if he even clicked on it. But who cares? All right, good night.